Hello learner, welcome once again to Manifested Online Classes. My name is James Kenyani. In today's lesson, we are going to start a new topic on the board written as further logarithms, meaning that you had covered some logarithms in book 2. So in this topic, it is important to review logarithms and use mathematical tables as discussed in book 2. In this topic, laws of logarithms and their applications is discussed. Objectives. 1. At the end of the topic, the learner should be able to derive relationships from index and vice versa. You'll learn of index form. B. State the laws of logarithms. Use logarithms to simplify logarithmic equations and expressions. And lastly, apply laws of logarithms in further computations. But as usual, we don't bite these at one bite. So you go step by step. So in today's lesson, we are going only to look at logarithmic notation. Logarithmic notation. It is logarithmic notation. So in this one, it is to enable the learner to express numbers in index form to logarithmic form. So as we began the lesson, it is further logarithms. And I think what you did in Form 2 is going to be of much importance before we get on to that. You've used logarithms tables. For example, in Form 2, in Book 2, we saw that logarithm base 10, 5 gives us what? It gave you, if you look in your tables, it is 0.6990. So from book 2, we shall easily come and understand that. So this simply means logarithm of 5 base 10. This means learner, this means 10 raised to 0.6990 is equal to 5. This is what they call the index form. That is the index form. And this is the logarithmic form. This is the logarithmic. This is the logarithmic form. So from there, it will be very easy for us to build up when we talk of changing from index form to logarithmic form. So if you are given 10 raised to 0.6990 is 5, to change it to logarithmic form, you'll say log of 5 to the base 10 is 0.6990. So it goes without saying that. It goes without saying that when a number so learner, that can be written as log, you can just borrow from that, log this a log of c to the base a is equal to b. Log of c to the base a is b. Let's look at any relationship here. Here, for example, This is our 5. 5 is equals to 10 raised to that. 10 raised to that. When we come to the logarithm, log base 10 5 is that. Log base 10 5 is that. So there is a close relationship. So when we have this is equal to that, when we write in logarithm, you see what happens. It is now log to the base 10 is equal to that one. Log to the base 10 is equal to that one. That gives us an easy, to relate easily. Like here when you have C is equals to A raised to B. Raised to B. It can be written as log of C to the base A is equal to B. So we shall look at examples. Consider the following. So you have to consider they are written in index form. It is 2 raised to 3 is equal to 8. The second one, 3 raised to 2 gives us 9. And 5 raised to -2 is equal to 1 over 25. So let's look at those examples and connect to this. You will easily connect to that. So you see, here we had 10 raised to that gives us that. 10 raised to that. So in this case, the base is 2. The base will be 2. It can be written as, in logarithmic form, you can say it is the same as log of 8. Log of 8 to the base 2 is equal to 3. That will be the logarithmic form. Log of 8 to the base 2 is equal to 3. Look at that. Log of 8 to the base 2 is equal to 3. Similarly, in the second one, learner, you'll say log of 9 to the base 3. Log of 9 to the base 3 is equal to 2. Is equal to 2. Log of 9 to the base 3 is equal to 2. The last one, it will be the log of 1 over 25. Log of 1 over 25 to the base 5 should give us -2. You can see the relationship here. If you can grasp the relationship here, it's very easy. I said when you have log of 5 to the base 10 is that. It means 10 raised to 0.669 gives us 5. Gives us 5. And you find now when the number on the opposite side of the equal sign comes here, the base is here. The base is always the number below here. It is always the number below here. There is also something to note. Something to note as we continue, learner. There is something that will be true in what I'm going to write. 2 raised to 0 is 1, learner. 3 raised to 0 is 1. 1,000 raised to 0 is 1. It means any number raised to 0 is 1. Any number raised to 0 is equal to 1. I can write this in logarithmic notation. I can write this in logarithmic rotation. Writing 2 raised to 0 is 1. To write in logarithmic notation, this is the base. It will be log of 1 to the base 2 is equal to what? 0. There is something you'll note. That is the logarithmic notation. When we come to the second one, 3 raised to 0 is equals to 1. It means log of 1 log of 1 to the base 3 is equal to 0. We come to the third one. 1,000 raised to 0 is 1. It means log of 1 to the base 1,000 should give you 0. So any number, the log of any number, the log of 1 to the base of any number will give you 0. It means it's also the same as saying any number raised to 0 is 1. Any number raised to 0 is what? 1. So when you convert to logarithmic notation, you can say the log of 1 to the base of any number will give you 0. It's going to be very important. The log of 1 to the base, the number down here is always to the base. The log of 1 over 25 to the base 5. The log of 9 to the base 2. So it will go without saying that that should never come out of your head. We proved here. Whether this one is a million, whether it is a trillion, it will still give 0. Which means even a trillion raised to 0, a trillion raised to 0 will give 1. So that one should not ever evaporate from your head, because it's going to be very important when we compute our work on logarithms. So as they said, we can't bite quite a lot. So having known how to change from index, this is index form, and this is logarithmic form. To change from index form to logarithmic form, you see what is happening? The number here always becomes the base. And the logarithm of the number you are talking about is 8. So the logarithm of 8 to the base 2 is 3. When you come here, 3 raised to 2, 3 becomes the base. And the logarithm of the number you are talking about is this one, 9. So you say the logarithm of 9 to the base 3 is 2. When you come to the third one, you say 5 becomes the base. So you say the logarithm of 1 over 25 to the base 5 is -2. You'll find this power now goes to the right hand side. So the basic thing that we wanted to get as an objective is changing from index form to logarithmic form. We've also found out that from this one, in index form, any number raised to 0 will give 1. Any number, whether it is a million, any number. So it means that if you write 1 to the base of any number, is 0. The logarithm of 1 to the base of any number, whether it is 1, 20, 60, 1,000, a billion, it will give 0. That leads us to that conclusion. So with that, I'll simply, in the assignment, so learner, that is the assignment. It is simply for you to change the following from index form to logarithmic notation. Another word for notation can be form. So it's similar to that. You are now changing to this. I've given the index form, so change to logarithmic form. 1, 4 raised to 3 is 64. 2, 7 raised to 2 is 49. 3, 2 raised to negative 4 is 1 over 16. 4, 2 raised to 5 is 32. That is 4. 5, 3 raised to negative 3 is 1 over 27. 6, 5 raised to negative 3 is 1 over 25. 7, 2 raised to 2 is 4. And lastly, 8, 2 raised to negative 3 is 1 over 1,000. So having gone through that, you'll go and change from index to logarithmic notation before we meet in the next lesson. So bye-bye, and let's meet able to continue. Bye-bye.